Hello! Welcome to my 6-part guide, the musician's guide to power attenuators. This is going to be done in a lecturing style because, as some of you may know, I spent 7 years as a lecturer at the University of Salford, and it's what I do best. That means you can treat these like a podcast. I'm mostly going to be talking. Throw your headphones on, listen to it while you work, pause it when you find something interesting, rewind, come back to it, look up things I say. They're also going to be delivered, hopefully, in a clear and easy to understand way. I don't like confusing things. I don't want to put formulas in. I don't want complexity. If you care about that, you can look it up after. This is for musicians who want to understand these things. What is an attenuator? Why would I want one? We're going to talk about valve amps. How do they work? Tube amps, if you're in America, talk about some of those terms you've heard: transformers, ohms, volts, watts, saturation, biasing. What are they? In clear language. We're going to talk about reactive attenuators. What's a reactive attenuator? Speakers, coupling, cabs, tone, types of, that gooey stuff of how things sound and what you're looking for. Then in part 4, I'm going to compare different attenuator types. We're going to look at how they're built, the construction. I'm going to look at some competitor products. Now, I think highly of my competitors for the most part. I think they're brilliant, and I'll talk about their strengths on each one and weaknesses and where everything sits alongside. And I hope that'll be very positive. I'm not going to shoot anyone down. I don't believe in doing that. Universal positivity. Number 5, get to the dirty bit. Problems and risks. We've all heard of amps going on fire. How did that happen? Why did that happen? Is yours at risk? We'll talk about it and how to avoid it and make sure you're safe, which generally you're going to be safe, but let's get into it. And finally, part 6, build your own attenuator. I'm going to show you my very, very first design from over 20 years ago that I built, perfectly functional, does the job, very cheap to make. And that's why I got into this whole attenuator thing, because I didn't want to pay huge money. I didn't have huge money. I was poor. And I made my own. It sounded great out of the box because I fluked it. And I'll tell you why and how to do that. So without further ado, let's get to the lectures. Today, let's just get into it. What does an attenuator do? Very simply, it lets you run your valve amp or tube amp at full power, but have less watts reach the speaker. Okay, that's all it boils down to. You want to have your stack up, I'll come to why in a minute, but you want to have your stack up loud, 100 watts, too loud. You insert this unit in between your amp and your cab, and it soaks up the power. That's really all there is to it. It's such a basic idea. So we have these hundreds of watts coming out. Some of it goes into a unit, speakers into the unit, turns 90% of it or more into heat, wastes that into the atmosphere, passes a few percent along to your speaker, et voila, your amplifier is working just like it intended. It is completely deceived into thinking it's on stage at Donington Monsters of Rock and thrashing away, and your speaker's going, it's all right, I've got a couple of watts here for you in your bedroom. And that's what it boils down to. But it's way more complicated, obviously, otherwise we'd all just do that. So that's what they are, that's how you use them. Why not just turn down? Now, unfortunately, it turns out that, well, you can't. It doesn't sound right. And the reason for that is that when valve amps were really popular, when they came out, we were making them as big as possible, 100 watts and up. We just wanted more, because there was no PA, there was no amplification. What you had was what you got. And if you went to a big gig or an outdoor gig, your only way the crowd could hear you was if you had enough watts. So they were made big. You were relying on them. And it turns out that the types of tubes that became popular, the L34s, the 6L6s that floated to the top of the market, being catted. I'm always being catted. They became synonymous with our music history. Those are the sounds we're now looking for. We're still looking for those sounds because they were good. There were lots of other valves and tubes used, but they didn't sound as good. So there was a filtering process happening at the time, and manufacturers settled on these because they were what worked. Now fast forward to now, and we want those tones still, but it turns out if we use smaller valves, tubes, they have a different sound. It's not the sound we want. So we're kind of stuck with those big, powerful tubes. It also turns out that they sound their best when they're being thrashed really hard. Okay. So you've got a little bed there. As usual, covered in cat. So yeah, derailed. Yeah, it sounds out that when you push them near their limit in their saturation point, so you run the valves at maximum, you get a lovely compression sound that's really rich and full of lovely harmonics. So we've got this perfect storm of problems. There's a particular era valve and sound that we've used for years that we like. We've over the years, all the competition using other valves that doesn't sound as good have sort of faded away, and we've settled on these. But they only work at their best when they're loud. So that's a huge problem. We can turn down. It just sounds different. It's not as good. Secondly, a lot of the amplifiers, nearly all vintage amplifiers, and a lot of people don't realize this, your volume control is a tone control. So to get the right sounds at the right volume, because your ears and your hearing changes a little bit as things get louder and quieter, we hear things differently. They added extra circuitry, and so the tone at say volume 7 is physically different to the tone at volume 5 because the circuit makes it different. On a lot of amplifiers we hear about the treble bleed cap, and this is part of the circuit. And what this basically means is that at low volume, it lets a lot of treble through to make it clear while you're rehearsing. As you turn it up, less treble comes through, so the sound gets bigger and fatter and warmer. So you've got an issue where at 7, turn it Marshall to 7 or whatever, you've got less treble and a fatter sound, and you've got a different hearing curve, and you've got the tube saturating, which makes this particular thing. So you can't just turn that down. Even if you were to use sort of a volume box, signal box in the loop, we'll come back to that, you're going to lose the power compression, even though you keep the volume curve. So turning down is difficult. So moving on to tone, we can't turn down, but tones are issues. So if we use a power attenuator, is it going to change the tone of the amp? And unfortunately, the answer is yes. In every single situation, without exception, yes. Now, you cannot make a transparent attenuator. This is simply because the sound of your amplifier is your amplifier's transformer and electronics coupling to your speaker. It's not a blind thing of sending some information and receiving. It's not like a digital system. The two parts are interactive. They're like this. So in our digital system, we used to say data, 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 and it goes receive, 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 and that processor totally isolated apart from the information. But in an analog system, when it pushes and it pulls, and there's a tension between them. There's like a compression. So you push and this comes out, and you pull and it comes out. And that interactive process means that if you were to insert anything such as a power attenuator in between those, they are going to change the coupling. You're going to change how the two items interact. And so what happens is your attenuator starts being seen by the amp as if it was the speaker. And so your amp changes how it interacts because it's now interacting with an attenuator. You cannot make that transparent because it is there. It is a physical object. All you can do is try and find an attenuator that is similar to the speaker you like. So some attenuators are a bit brighter and some are a bit darker. If you're used to a brighter speaker, you'll prefer a brighter attenuator. If you're used to a darker speaker, you'll prefer a darker attenuator. It's really that simple. And when someone says to you, oh, such and such a brand is transparent, what they mean, they don't realize, what they mean is, I happened by chance to buy an attenuator that sounds like the speaker that I know and love. So to me, that's transparent. And when they say, oh, it's muddied slash, thinned my sound, what they mean is, I have bought an attenuator that is either fatter than my speaker, muddy, or brighter than my speaker, thin. And it's just really that conflict. So An attenuator will change your tone, and you have to really figure out what they're going to sound like by reading reviews, or if possible trying one out and seeing if it suits you. I can tell you for a fact that the Audiostorm Hotbox 120s that we make are designed to have a lot of clarity at the top end, that's how I like to say it, but basically they don't roll off, they don't go mud. And so if you like brighter, sort of clear, crunchy sounds, they're for you. If you're looking for something sludgy and fudgy, maybe not. The 130s that we make with the switchable reactive stuff, they're a little bit warmer. They give you a bit more control, but we're still a clarity-based brand. That's what we make. We don't make a sludgy attenuator. Just don't. Moving on, because we'll come back to that too. Okay, so can't return down. It's going to change tone. Sounds terrible so far, doesn't it? Just use a small amp. Oh, I see this all the time on forums. Just use a small amp. So I'm just going to quickly get to the point on this one. It's different. It's different tubes. It's different speaker. If you need a truck, you need a truck. If you need a motorbike, you need a motorbike. They're not interchangeable. They both drive. They both move. They're different things. I love small amps. I've got some fantastic small amps. They sound great. Sometimes I'll take one into a studio where that close miking and the sound's really good, but it is just different. It's a different amp. Why should I have to sacrifice my 100-watt Marshall stack, which is in my front room, by the way, with one of my attenuators on it? Of course it is. Why would it not be? Why would I give that up? I love that amp. I don't want to give that up to use a small amp just to make you happy and you're a small amp. So fundamentally, it's a different beast. That's your answer to that. Small amps and big amps sound different. Same thing as everything. If you change something, you change something. Attenuators don't work for me. This is a common one I hear on the forums. Sometimes I get a customer comes to me and will say, I've tried 5, didn't like any of them. Will yours be the revelation I need? And my answer is, nope, it won't. Sorry, just stop. Just stop right now. I mentioned earlier about how you have to drive tubes really loud, really hard to get that compression, how we have to set the amp a certain way to get the tone. There's another factor you're hearing. You physically hear things different at 100 dB to 80 dB. At 110 dB, there is a different process going on. You've got different neurological signals happening in your brain. You've literally got different electrical things firing. You've got different densities. It's different. You cannot, if you turn down, you can, and this is the key, right? If you turn your amp down with an attenuator, with the right equipment, if you reduce the volume, you can get the exact same tone at a lower volume, but it will not feel the same. It's just not going to feel the same. It's the difference between being in a nightclub with the music pounding and listening to a song on earbuds. The tone isn't what we're on. And so you've got to ask that question, first of all. If you think you're a person that attenuators don't work for me, and if you're coming to this with a very negative attitude, oh, it's never going to work, I don't want this, don't waste your money. Don't be pushed into it, right? If your bandmates are saying to you, you need to get an attenuator, and you're really like, I don't want to, I don't like it, I like my amp, then just practice turning down. You don't waste your money. Attenuators are amazing. Power attenuators will let you get that like live sound of the 60s in your front room, but what they won't let you get is the feel of being at a gig in your front room. That feeling, that rush of adrenaline, that pounding in your ears is not what a power attenuator provides. They just provide the sound. Very well, very good. I'm saying this with genuine kindness because I have come across people who've spent a fortune on attenuators trying to, and I think when I chat to them, a lot of the time it's peer pressure. There is an element of saying, I think people sometimes you buy one just to satisfy your bandmates or to satisfy your housemates, and I think that's more of a psychology issue than a attenuator issue. Okay, signal versus power attenuators. Now this is one that crops up quite a lot. I didn't bring any, but so I make a tiny plastic box, a volume box I call it, on my VBM. That's at £20 or so. 25 on Amazon at the moment. I don't remember. It's as cheap as I can make it. Honestly, a third of the money goes just to Amazon fees. What can you do? Um, and sometimes what happens in this little box is I get people buy it, plug it into the output on an amplifier, and then return it to me saying, how was I supposed to know that this plastic box this big would burn up and melt? You've made a faulty product. Or sometimes they just go, doesn't work, send it back. And I get it back, and I don't even open these things. I just smell them and go, yeah, I've been. I know exactly what's happened. Stickers on site information. But I appreciate, and this is why I'm doing these lectures, I appreciate it's not meant to ridicule anyone, that you don't know. Why would you know? So our amplifier puts out 100 watts. 100 watts is a lot of energy. It's not just a volume. In fact, it's not a volume. A volume is measured in decibels. A watt is a measure of sort of energy. It's a measure of power. It's how much electrical force is going through a thing. And that's why any good power attenuator needs to have a chunk of metal on it or cooling. You can't get away from that. You're going to dissipate. You're going to try and convert a lot of watts into warmth and get rid of them. So if you don't see a big metal heatsink, it's not going to do that. A signal attenuator. Now, the word attenuator just means reduce. To attenuate, reduce. So a power attenuator is reducing the power. It's reducing the watts. A signal attenuator is reducing the signal. It's reducing the volts. Now, volts is like just a part of the equation. When we talk about volts, it's abstract. Power is solid. 100 watts is 100 watts. You can get it in different ways, but 100 watts is always power. So with our signal, what we really mean is, and this is how it works, the voltage that comes out of your guitar is measured in millivolts. It's measured in thousandths of a volt. And the current, which is like those two things go together. The volts is also milliamps. It's not even milliamps, microamps. So small. So, but it's like how should we say? It's a symbolic representation. So the electricity that comes out of your passive pickup is literally generating. But your guitar is a generator. It generates electricity. When the string vibrates in the magnetic field, it actuates a coil of copper and literally is making electricity. You are making it, but the amount is so feeble, it's so fragile that you can't do anything with it. And that's what we call a signal. So what it means is that waveform of your string vibrating is quite literally generating electrical current that matches it. And if we're very gentle with that, we can copy that and take it into a pedal. We can copy that and take it into an amplifier. And in an amplifier, we will amplify it from this gentle signal, this symbolic representation, up to a power where it can push a physical cone of a speaker in and out. So when we have a signal attenuator, we are altering the symbolic representation. So what we're really saying is we've got this voltage of a few millivolts representing a string vibrating. We're going to halve it and make it a little bit less in millivolts. Or in the case of even a treble booster or a clean boost pedal, we're going to take that millivolts and make it 100 millivolts. Still less than a volt. We're not even at a volt. It's still a fraction of the power that goes into a battery. We're so low. And so a signal attenuator just uses a variable pot. Now those pots are typically rated, to put this in perspective, at 0.1 of a watt maximum. So that's the concept. Very, very simple. A signal is a very small representation of electricity. I mean, it is electricity, but it's so small that if you try and put it into anything, it evaporates. Power is when you've taken that signal and amplified it and beefed it up and put some energy behind it so it can do work, like push a speaker. So those are your signal attenuators, such as I think the JHS black box. That's one. It's just a volume pot in a box. Our VBM volume pot in a box. We also do the loads of different things, and everyone does these things. So you're playing with signal versus power. You get the point. I'm over talking. So right one for the right problem. So a signal one effects loop, I should say. The effects loop, you still got that very low level signal. And yeah, solid state amps. Occasionally I get someone ask me, can I use a power attenuator with my solid state amp? The short answer is no, absolutely not, and you shouldn't do it. The whole purpose of the attenuator is to let you drive your valves and tubes to that saturation point that has where the compression starts. Transistors, solid state, do not have that point. It does not exist. What they have is something horrific called thermal runaway. So in a tube or a valve, as they get hotter, the power actually reduces slightly. So they have a natural safety brake. And this is one of the reasons why tube amps are so amazing. If you take your 100-watt stack to 100 watts, it won't get any louder because it starts overheating. The tubes actually internally get hotter than hot. I mean, they're already hot. They get too hot. And as they get too hot, the power actually reduces slightly. And that's the compression, is the power reducing as they heat. With a transistor, the opposite is true. If they get hot, they conduct more. So if you were to put a power attenuator on a transistor-based amp, as they hit 100 watts, you're now thrashing them harder than ever. They're either going to hit 110, 120, go into thermal runaway, and they're literally going to go 200, 300, 400, explode into fire. So transistors, they don't have a compression point. They don't sound nice when they're overloaded, and they will have thermal runaway, which will kill them. You'll literally kill your amp. Do not plug a power attenuator into a solid state amp. This includes MOSFET. Sorry. Yes, MOSFET, the valve state 100 amps, things like that. And MOSFET's a little different. It does have a negative temperature coefficient, which means it acts like a valve. It will, you hit that threshold, the power reduces, but it's not particularly nice like a valve necessarily. I think my opinion on this as an electronic engineer is you could run an attenuator on a MOSFET, but I wouldn't. I don't think the advantage is there. I don't think you're going to get much of a tone benefit out of it. It's just going to sound harsh. You know, it's not the right tool for the job. So yeah, solid state, just please don't. Sorry. Speaker cables, this comes up. Going back a little bit to signal versus power, our delicate little signal, our millivolts from our guitar is so fragile that the electrical energy around us from smartphones, from radio, can actually interfere with it and ruin it and distort it and add hum and hiss, which it does, mains hum, hiss noises. So we need a screened cable. So what we normally do is have a really, really nice quality, maybe silver plated core in the middle, and we wrap that in an earth screen that's designed to keep out the universe and keep it pure because it's so fragile. Our power signal is very, very different. Our power signal, there's lots of energy going down it, so those thin little cores are not good enough. So you shouldn't use a signal cable, a guitar lead, as a speaker lead. First of all, because it's just too thin. It's going to actually start heating up and warming up like a fuse. As best case scenario, it'll just get a little bit warm, and what will happen is you'll actually lose some power in the cable, which means that your amplifier will see the wrong ohms, and it's just messy. Worst case, well, slightly hard to explain this too, but a guitar cable has capacitance. So anytime you take two metal plates and hold them together, I've made a capacitor. There we go. That's now a capacitor. In fact, they've got rubber feet, even better. So there we go. That gap has made a capacitor. It's probably just like a picofarad if I'm lucky. But that's a capacitor. That's now actually going to store in that gap. It's storing charge. Really. So a capacitor, the more surface area you have and the closer it gets together, the bigger the capacitor value. So in a guitar lead, you have quite a lot of capacitance because that screen has a lot of surface area and it's very close to the central core. So you develop this huge capacitance. That creates a tone filter with your transformer. Now again, it's very subtle, but it means that when you use a guitar lead into your transformer, you've not got enough wire to pass the power. You're losing watts through the cable, and you've added a capacitor to the output of your transformer, which creates a tone filter, so you're mucking up the tone. So it's just bad in every way. A good speaker lead is very simply two pieces of chunky copper wire with no screen. It's a very different beast. It might look the same on the outside. You can just use a piece of mains flex if you want Perfectly, nothing wrong with that. Perfectly good piece of wire. Or generally better quality speaker cable. The main advantage is it's just tougher, more reliable, more flexible. Mains cable tends to, the copper strands tend to be a bit thick. The quality wise, tone wise, no difference between some cheap mains cable from your local hardware store and a fancy speaker cable, none. But it's really about the fact that the cores are not as flexible in a mains cable and they'll snap over time. Whereas a good guitar cable, they're very, very fine, they're very well wound, they have better quality sheaves, they're designed to be thrown around and flexed day after day, and that you're paying for that reliability, mainly the niceness. So please use speaker cables. Simple as that. Do not use screened cables, do not use guitar leads. Combo amplifiers and wiring. This is a tough one to chuck in here, actually. I need to put this in. Sometimes you get a combo amplifier and there is no speaker socket. So in this case, you need to get in there, and I'm very sorry, you just need to get that wire that goes from the combo to the speaker and in some way cut it, pull it off, or insert the hotbox there. You can't use it in an effects loop. It doesn't work. We make the combo box kit, which makes this process easier, but you're going to have to get your hands a little dirty however you do this and add some kind of way of adding a jack socket. Our kit has a sort of send and return speaker socket on it, so you have a way to have your normal sound and then slot the hotbox in when you want it out. I think it's quite cool. Again, even on some amps, it's not going to work. So always look at the back of your combo and have a think what's there and see if that's going to work. If you're using it with an extension cabinet, much easier. If they have an extension cabinet socket, great. You can plug in and use an extension cabinet. If it's a type of combo amplifier where the speaker comes, sometimes you get the wire comes straight off the speaker to a jack, that's great too. Just unplug that jack, that's your output. Insert it there. Unfortunately, I say again, we're going back to an era, especially say with Vox amplifiers, the old AC30s and similar, where no one was thinking, let's make this quieter. Everyone was thinking, we need this louder. Yeah. Okay, so there we go. I hope that's a useful week one overview. I know it's a little lightweight. So power attenuators reduce the amount of watts that reaches your speaker. You simply plug them in line. You can't turn down and expect the same tone because the vowels that we like historically need to be run loud and the tone control spots are physical. They will change your tone, so do your research, find out which ones you like and try and go down that road. A small amp's a different beast, great, but it's a different thing. You may not like attenuators. If you don't like them, accept it. Stand up to your bandmates and tell them to get in the sea, and you're not going to use one. Signal attenuators are a different thing. Delicate signals versus brute force. Solid state amps are not appropriate. Speaker cables are a good thing. Use them. Combo amplifiers are a pain in the neck. And we love attenuators. Right? That's what it's all about. Stay with us. Part 2 coming soon.